So welcome, this is Cambridge A level 9709 October November 2022 Probability and Statistics 1 paper 51. First question, this is from probability distribution table. So we said what shall we do? Sum of all probabilities is going to be 1. So I'm going to add it out. P plus Q plus 0.16 plus 0.3 equals to 1. This gives you one equation, P plus Q equals to 0.42. Then I take the expected value 0.12 times -2, negative p plus 0.5q plus 0.16 plus 0.6 equals to 0.28. This gives you another equation, negative p plus 0.5q equals to negative 0.24. Two equations I got it out. Now solve these two equations. P plus q equals to 0.42. Negative p plus 0.5q equals to negative 0.24. So 1.5q equals to 0.18, q equals to 0.12. Plug in q as 0.12 equals to 0.42. So p equals to 0.3. Next, question number 2. The residents of Persham were surveyed about the reliability of their internet service. 12% rated as poor, 36% as satisfactory, 52% as good. A sample of 8 residents in Persham is chosen. Find the probability that more than 2 and fewer than 8. 2 and 8. So probability of x equals to 3 plus x equals to 4 plus x equals to 5 plus x equals to 6 and probability of x equals to 7. Now their internet services poor or satisfactory means poor or satisfactory only has supposed to be added. So my probability of success is going to be 12 plus 36, which is 48%, 0.48. So failure will be 0.52. So out of 8 times, 3 times is success and 5 times will be failure. Out of 8 times, 4 times is success, 4 times is failure. Then 5 times is success, 3 times is failure. 6 times is success, 2 times is failure. 7 times is success, and 1 time is failure. So simplify that, you should be getting it out 0.825. Next one, out of 125 residents, n is 125. Find the probability that more than 72 residents rate their internet service as good. So what is P over here? 0.52. So find the mean. Mean equals to NP, which is 125 times 0.52, which is 65. Then standard deviation is square root of NPQ, which is square root of 125 times 0.52 times 0.48, which is 31.2. Now what is he asking? Probability of x greater than 72. So probability of z greater than 72.5 minus mean 65 divided by square root of 31.2. So probability of z greater than 1.343, which is 1 minus probability of z less than 1.343, which is 1 minus 0.9104, which is 0.0896. That's going to be the answer. Question number 3. Draw a back-to-back stem and leaf diagram. So for this, I draw the stem and leaf. This is for lions and this is for tigers. It is 16, 17, 18, 19, 20. So first start with lions. In 16s we have 169. Then in 17s we have 178 and 179. So I am filling it up that one. As such, already I have done it out. So I am directly writing the answers over there so that it will save over time. Then for this tigers, I write it out over here 0, 3, write in order 0, 1, 4, 5, 7, and 1. Don't forget to write the key. key write as 1/18/3 means, what does it means? 181 centimeters for lions and 183 centimeters for tigers. Find the median and the interquartile range of the heights of the lions first team squad. So how many are there? Totally 3, 6, 9, 10, 11 are there. So 11 is an odd number. 11 plus 1 divided by 2. So which is nothing but what? Sixth term. So sixth term, which is the sixth term? 1, 2, 3, 4, 5, 6. Sixth term. So 186. So Q2 equals to nothing but what? 186. Now there are totally 11 terms. So sixth term is a Q2. So over here I have 5 terms and over here I have 5 terms. 5 is again a odd number. So for Q1 is nothing but what? 5 plus 1 divided by 2, which is third term. So what is the third term? Third term is nothing but what? 179. So lower quartile is 179. Now finding the upper quartile. So to Q3 again 5 plus 1 upon 2, third term from the Q2. So it's going to be nothing but what? 1, 2, 3, 190. So which is 190. So interquartile range is equals to nothing but what? Q3 minus Q1. 190 minus 179, which is nothing but how much? 11 centimeters. It is given that the tigers, the lower quartile range is 173, the median is 190, the upper quartile is 195. Make two comparisons between the heights. So upper quartile for the tigers is nothing but what? 195, whereas it is only 190. So we can say that tigers are taller. Tigers are taller. Then any another one. So we can see that the difference is nothing but how much over here? 7. And the difference between over here and this one is nothing but how much? 5. Whereas for tiger lions, when we see that one, the spread, it is how should I see that? 186, 179, 186, 179, and 190. It is 4 and 4. It is same. So they are consistent. So we can say that lions are consistent because the difference is same. Lions are consistent in heights than tigers. This is a two comparisons. Question number 4. In a large population, the systolic blood pressure of adults is normally distributed with mean and standard deviation. Find the probability that chosen adult is less than 132. Probability of X less than 132. Probability of Z less than 132 minus 125.4 divided by 18.6. Simplify that. Z less than 0.3548. Check from the table 0.639. The SBP of 12-year-old children in the same population is normally distributed with mean, and children of these children 88% have more than 108. So greater than 108 is 88%. So probability of Z greater than 108 minus mean is 117 divided by sigma equals to 0.88. So probability of Z greater than negative 9 upon sigma equals to 0.88. Convert greater than to lesser than, Z less than negative 9 upon sigma. Now convert lesser negative to positive. One more time, 1 minus probability of Z less than 9 upon sigma equals to 0.88. So probability of Z less than 9 upon sigma equals to 0.88. So from there, I get 9 upon sigma equals to 1.175. So sigma equals to 7.66. That's going to be the answer. 3 adults are chosen at random from this population. Find the probability that each of these 3 adults has SBP within 1.5 standard deviations of the mean. So they have 1.5 standard deviations of the mean. So probability of minus 1.5 to Z less than plus 1.5. So whenever I have less than two numbers, bigger number, 1.5 standard deviations from the mean. So it becomes probability of z less than 1.5 and minus probability of z less than negative 1.5. So what does it becomes? Basically, whenever I'm doing it out like this, rather than doing in this way, what am I going to do? Let me do it out clearly. He is asking, find the probability that each of these three adults are within 1.5 standard deviations from the mean. So 1.5 plus mu or mu minus 1.5. So probability of mu minus 1.5 is less than x is less than mu plus 1.5. This should be the way. 1.5 standard deviations. Sigma, sigma and sigma. So whenever I have lies between second number minus first number. So z less than mu plus 1.5 sigma minus mu upon sigma minus probability of z less than mu minus 1.5 sigma minus mu upon sigma. So what does that happens? Mu and mu gets cancels and sigma also gets cancels. Probability of z less than 1.5 directly right. Last time I was writing it out directly. Now I wrote it out with all the steps. So probability of z less than 1.5 minus 1 minus probability of z less than 1.5. So it becomes 1 minus. So it becomes 2 probability of z less than 1.5 minus 1. So it is 2 times 0.9332 minus 1. Simplify that, you should be getting it at 0.8664. That's going to be the answer. But for this is only for 1. But he is asking that it should be 3 adults. It should be 3 adults. So first adult is 0.8664, the second adult is 0.8664, the third adult is 0.8664. So multiply all these 3 times, it will become 0.650. Question number 5. A game is played with an ordinary 6-sided die. The player throws the die once. If the result is 2, 3, 4, 5, that the result player is score, that result is the player's score and the player does not throw the die again. If the result is 1 or 6, the player throws the dice for the second time. And the player's score is the sum of the two numbers from the two throws. Draw a fully labeled tree diagram to represent this diagram, to represent this one. So what am I going to do it is going to do it out for 1, for 2 he is not doing, for 3 he is not doing, for 4 he is not rethrowing it out, for 5 he doesn't rethrows, whereas for 6 again he rethrows. So for 1, if he gets 1, he throws it for the second time. So 1, 2, 3, 4, 5 and 6. For 2, 3, 4 he does not. For 6 again he throws 1, 2, 3, 4, 5 and 6. So this is for 1, this is for 2, 3, 2, 3, okay, rather than writing it out like that, 2, 3, 4, 5, 6. For 2, 3, 4, 5, he does not rethrow. This is for 1. This is for 6. 1, 2, 3, 4, 5, 6. Now, probabilities. This is 1 upon 6, 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 1 upon 6. Then again this is 1 upon 6, 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 1 upon 6. 1 upon 6, 1 upon 6, 1 upon 6, 1 upon 6, 1 upon 6 and 1 upon 6. This is the tree diagram. Next he says that show that probability of A is 1 upon 3. What is A? The player score is 5, 6, 7, 8, 9. So 5. So first of all, he should get 5. How can he get 5? He can get 1 plus 4 or 5. 1 plus 4 is 1 upon 6 times 1 upon 6, or 5 is 1 upon 6, which is 7 upon 36. Next, he can get 6. How he can get 6? 1 plus 5. 1 plus 5, so which is nothing but what? 1 upon 6 times 1 upon 6, which is 1 upon 36. Next, he gets 7. How he can get 7? 1 plus 6 or 6 plus 1, which is 1 upon 6 times 1 upon 6, or 1 upon 6 times 1 upon 6, which is 2 upon 36. Then he gets 8. 8 is only the way 6 plus 2, which is 1 upon 6 times 1 upon 6, which is 1 upon 36. And he gets 9. How he can get 9? 6 plus 3, which is 1 upon 6 times 1 upon 6, which is 1 upon 36. So add them all. Probability of A will be 12 upon 36, which is 1 upon 3. Describe whether or not A and B are independent events or not. What is B? Probability has two throws. Probability of two throws. Two throws is nothing but how much? This 6 times is through two throws, and this 6 times is two throws, right? So probability of two throws is nothing but how much? 2 upon 6, which is nothing but how much? 1 upon 3. Now probability of A intersection B. A intersection B is nothing but how much? 6 upon 36, which is 1 upon 6. Now, for independent, probability of A intersection B should be equals to probability of A times probability of B. So 1 upon 6 equals to, this is 1 upon 3 times 1 upon 3, which is not possible. So therefore, not independent. Probability of B given that A complement. So probability of B intersection A complement divided by probability of A complement. Probability of A complement means 1 minus 1 upon 3. Probability of B intersection A complement, just now we have done that one, is nothing but how much? 6 upon 36. So simplify that, which is 1 upon 4 or 0.25. Question number 6. A social club has 15 members, of whom 8 are men and 7 are women. The committee of the club consists of 5 members. Find the number of different ways in which the committee can be formed from the 15 members if it must include more men than women. Men and women. How many men? 8 women, 7 women. So 5. So 5 0, 4 1 and 3 2. So it becomes 8C5 times 7C0, 8C4 times 7C1, 8C3 times 7C2. This is 56, this is 490, this is 1176. Add them all, 1722. Next part, the 15 members are having a photograph taken. They stand in 3 rows with 3 people in the front row, 5 people in the middle row, and 7 people in the back row. In how many different ways 15 members can be divided into 3 groups? So first I'll draw 15C3. Then I go for, out of 15, 3 people are over, so 12 people are left over. Then I have to choose 5 people for the middle row. So 12C5. This is for the front row, this is for the middle row. Then again 5 are over means 7 people and 7 only. The back row, 7C7. Simplify that, 360, 360. In one photograph, Abel, Betty, Kelly, Doug, Eve, Freya, and Gino are the 7 members in the back row. In how many different ways can these 7 members be arranged so that Abel and Betty are next to each other and Freya and Gino are not next to each other? So totally how many people are there? 7. 7 units minus, I take these two people, Abel and Betty together, minus Abel and Betty, Abel and minus Betty, 2 units. Then again add them as 1 unit. So 7 units minus 2 units plus 1 unit. Well, these are 2 units. 7 units minus 2 units plus 1 unit is nothing but 6 units. These 6 units can be arranged themselves in how many ways? 6 factorial ways. Times, again AB and Betty can be arranged among themselves in 2 factorial ways. So this is the total number of ways. But again, I don't want Freya and Genya next to each other. In this, Freya and Genya can be next to each other. So therefore, what am I going to do? 7 units minus that AB and Betty and minus Frio and what are the names? Gino together, plus what am I going to do it on? 7 units. This is 7 units minus this is what? 4 units, and AB and A and B together as 1 unit and G and F as 1 unit. So again, this is 1 unit and 1 unit. So totally 5 units. So 5 units can be arranged in 5 factorial. Again, AB can be arranged among themselves in 2 factorial and GF can be arranged among themselves in 2 factorial. This is what AB together, AB and GF together. So from the total ways, 6 factorial minus 2, if at all I subtract this one, I will be getting where GF is not together. So what is that? If I subtract the number of ways in this way, I will be getting it out of GF which is not together. So simplify that. This is 1440 minus 480, which becomes 960. So in this way, both what it says only AB is together. So GF this way will be having both GF together and not together. If at all I am subtracting GF together, then I am left over with is nothing but what? GF not together. So this is going to be the answer 960. So that completes the paper. See you in the next paper. Bye.